So now, let's use this to talk about a great example, my favorite examples, of welfare analysis in the real world, which is taxi cabs and taxi cab medallions. Okay, how many people here have taken a taxi? Okay, it's actually the single word that's the same in the most languages around the world, is taxi. Okay, it's a very common concept. We all know about taking taxis. Okay, but what we don't often know a lot about is the key restriction in taxi cab markets, which are called taxi cab medallions. A taxi cab medallion is essentially, used to be literally a medallion, it's now a piece of paper, that you have to legally operate a taxi. You have to have a taxi cab medallion. Now, what that does is it limits the amount of taxis on the road. And we want to ask is, what are the welfare implications of those limitations? Okay? So let's start with a positive question. What happens when you limit the number of taxis? And then, which is what we could have, hopefully, it'll just be a review of things you already know how to do. Then we'll go to the normative question, which is how do we feel about it? So let's go to figure 13.8. Okay? This is complicated. This is one of these figures we have to go back and forth. So let's go slowly through this, and please, please stop me if you have questions. On the left, we have a typical cab firm. We're going to assume all taxi cab companies are identical, which is actually not terrible at all in the taxi cab market. So assume they're basically all cabs are identical. And the question is just how many taxis will be in the market. So every taxi, say, works an 8-hour shift. They charge the same price. They get the same gas mileage, or the same thing. The question is how many of those 8-hour shifts are going to be in the market. That's the only question we have to ask. Okay, so let's say that in a perfect competition, on the right we have the market for taxi rides. The demand curve for taxis is D. Okay, the supply curve is let's just say it's horizontal. Let's make life easy. Well, actually, no, let's not say it. Let's follow the tenets of perfect competition and say that in the long run, supply will be horizontal at the minimum average cost. Minimum average cost you see is price P1. So from the left-hand side, we can see that the long-run competitive price must be P1 because that's the minimum of the average cost of taxi cabs. Now, once again, if taxi cab companies are heterogeneous, we'd have something like the cotton market, and it would look different. But for now, we have a flat, perfectly competitive, identical firms, no barriers to entry. Okay? When there's no medallions, anybody can just say I'm a taxi and drive around. No barriers to entry. Anybody can say that. Then in that world, you have a flat supply curve, and you'll have equilibrium with big Q1 rides being demanded at a price P1. Now, since firms are identical, each firm must provide the same amount. We know at a price P1 how much a firm will produce. They'll produce where their marginal cost equals that price, which is little q1. So what you have is a set of firms producing little q1. You want to get to a total of big q1, so that means you're going to need n1 firms. So the initial equilibrium is n1 firms. Let me once again go through the logic. This is something which is reviewing what you learned. The market gives us, the left-hand side gives us the price, because the price, so we're going to go left to right to left, okay? Actually, no, left to, I don't know, we'll do it, we'll see what happens. We start in the left. We know in the long run firms produce the minimum average cost, so we know they produce at P1. We bring that over to the right. We know at a price of P1 that big Q1 will be demanded, okay? Now going back to the left, we know that for every firm at that price, P1 is producing Q1, little q1. Going back to the right, if every firm is producing little q1, there must be n1 firms to get the big q1. Okay? That's our market analysis. That's the positive analysis. Now let's do the positive analysis of what happens when we introduce a supply restriction. In particular, we say that there can only be N2 taxi cabs in the market. We restrict the quantity to N2. We set up a barrier to entry. Only N2 taxi cabs to be in the market. Well, now we say, okay, let's go to the right-hand side diagram, look what happens. Well, with N2 taxi cabs, if they all produce the same number of rides as before, which was little q1, we would have a huge excess demand. Okay, there'd be N2 Q1 being produced. But at that price P1, people would want way more rides than that. So you'll say, no, we want more taxi cabs. We want more rides. What that means, however, is you can't meet that by more taxi cabs entering. So how do you have to meet it? By each taxi cab working harder. Okay? Well, if they're going to work harder, what are they going to do? Charge a higher price. Indeed, the new supply curve is S2. It's flat up to that point N2Q1, then it slopes upwards. Because since you can't meet demand with more firms entering, you have to meet demand with more hours being worked, and that lowers efficiency. Because the efficient number of hours was little q1. That was the efficient number of hours to drive. If each taxi cab driver is going to have to drive more, they're going to be tired, they're going to drive less efficiently. And therefore, you're going to move up the marginal cost curve on the left-hand side to produce at a less efficient level, and therefore you're going to have to charge a higher price. And the new equilibrium will be P2, with little n2 drivers producing little q2 rides each. Okay? Because that is the point. They're still at the minimum average cost, but for this new cost function. Okay, this is the new equilibrium, which with only n2 drivers, it's less efficient to produce. So they produce little q2 at a price P2. Okay? Little q2 at a price P2. Now, that's the positive analysis. Questions about that? That's pretty hard. Questions about that? Yeah?
I'm sorry, could you just explain again, like, why? So they have to work harder?
Well, in other words, Q2, little q is how hard they work. Each firm works. So each firm, since there's only n2 firms in the market, okay, each firm is going to have to work harder. Because if n2 firms produce little q1, there's excess demand for rides. So people are going to be willing to pay more. They say, hey, taxi cab, I'll pay you extra to give me a ride. So therefore, taxi cab will say, fine, I'll work harder, but I'm going to work harder, I'm going to charge a higher price. Because now I'm no longer at my old average cost. I'm not that efficient point. Now I'm going to get tired, stuff like that. So I'm going to charge a price. That means supply curve is suddenly going to pivot and slope upwards. That's S2. I'm going to work my way up that upward sloping supply curve till it equals demand. And that will happen at price P2. And that will be the new equilibrium price. And now every taxi cab driver will work harder. They'll produce little q2 hours of driving.
So the increase in cost, why is that a new average cost curve rather than moving up the old average cost curve?
Well, it's basic. I go back and forth about whether to show this. Technically what it is it's saying the old average cost curve was the average cost when the market had more participants. But as the market participants falls, the average cost of the market falls. So think about our cotton diagram. Okay? Suddenly, if the average cost is the average of all those countries, suddenly if Pakistan drops out, the average cost is going to be higher. Okay? So basically, you're suddenly, if you're restricting the number of people in the market, everyone's producing at a less efficient scale. I think the average cost it doesn't help intuition, but it's technically right. Really, the key point is to follow the intuition of what I said. Okay? Good question. Other questions about that?